Right, should we get started? Let me share the screen. Okay, so we have two agenda items today. Othering, are you there? Looks like this one is a, sorry, have some chat, sorry. Looks like this one is like leftover items that we haven't discussed last few times. Othering, if you are not there, we're gonna move that again to the next time. Okay, so sounds like you're not there. By the way, can you guys hear me? Hello?
Yeah.
Okay. All right, so sorry, Julian, do you want to start on this one?
Yeah, so this is basically adding a new RPC to the node plugin that provides drain capability. And the idea is with some kinds of volume drivers, particularly with Fuse, all sorts of strange things can go wrong, right? So you can have a volume that's in use in some way, so it doesn't terminate cleanly. So often you can end up with leftover mount points. And that's just kind of an example. I think there probably could be other, there may be other examples that with iSCSI or things like that, where things maybe didn't timed out at shut termination or unpublish, and we end up with these kind of leftover cruft on the operating system. And if that stuff's left to accumulate, it can cause problems.
Mm-hmm.
So node shutdown is kind of a one place where we know that there shouldn't be any mount points for a plugin. Like anything the plugin's made is very likely not something that you want on the OS. So the idea is like after everything else is, after we've called unpublish, we're getting ready to terminate the node because we've unscheduled all the workloads on the node. Call this drain RPC, and that gives the plugin developer a central place to put in cleanup logic. James made some really good comments, and I think we'll go back and add the error codes and clean up the formatting, so that's non-controversial. The one question I had, and the reason I wanted to talk about this again was, so he's asking like, well, why should we say that it's an error to call other RPCs after drain has been called? Because you might want to call drain at node startup time too. And I think that's a really good point. If we do that, then we have to change the expectation that the plugin should terminate after drain, right? Because starting up and then draining and then terminating the plugin is not going to help anybody. But I think that that's a fine change to make. We can handle termination of the process, obviously, in whatever way that normally happens with stuff running in a container. So I guess the expectation would be while drain is happening, like after you've invoked drain, but before it's responded, we shouldn't have other RPCs called. Because draining, like if you try to publish something while you're in the middle of draining, that could be very bad.
So I have one question there. If you're saying that the first RPC to call is no drain, like how do I figure out this plugin has no drain capability if that's the case? Do I have to call like at least like no get capability first to figure out, oh, this plugin has no drain capability, and then call no drain?
Yeah, it wouldn't have to be the first RPC. It would just have to be, so the CO, like the plugin doesn't know when it's starting up whether like it's starting up as part of a normal startup process on a clean node, or whether it somehow unexpectedly terminated and the CO is restarting it. So I don't think when the plugin starts up, we can't just assume that the node it's running on is clean, but the CO knows, hey, this is a node that has no work scheduled on it, and we're just starting it up. So this would be an appropriate time to blow out the cobwebs, as James says.
Okay, so let's assume that the CO knows about that. This is like a clean node that no one has run anything under the node before. The CO startup and call the plugin like node get capability to figure out like the capability of the node plugin, and then call node drain. Is that like a requirement that the CO needs to call that, or I just want to figure out like what the CO logic should be.
So I guess if we're gonna write that in, then I would put that as a should,
Okay.
rather than a must, because I don't know if that's practical for all COs, and I think you could decide what makes sense. In the case of Mesosphere, like, does it make sense to do this at startup rather than shutdown? In a way, it doesn't matter, right? If the idea is like we've got leftover mounts or leftover mount points that don't actually have fuse processes associated to them, or things like that.
I see. Okay.
Yeah, implementing this on the Kubernetes side would be non-trivial. So I would like to see a very clear benefit if we are going to add it. I don't think it's worth adding with a should implement, because at that point, if some COs implement it and some don't, it doesn't really, like, it shouldn't be in the spec.
Well, so the trouble is that if we don't do this, then essentially, if I, as a plugin author, want to put some logic someplace that does this kind of cleanup, and what we've found is that with anything fuse, this is a very good idea. That means that the plugin author can't do that in a CO agnostic way. That's why.
So I have actually a related question about this related to node drain. A question I have is that, without this node drain, we can have a situation that the CO used the plugin to publish the volume, and then the node got rebooted. Yeah. So in that case, a stateless plugin would, currently if it's a stateless plugin, they could probably just have no problem with, the CO may have no problem to use a stateless plugin after it rebooted because the mount table is cleaned up. So the CO might be able to assume that the volume is we'll go back to a node ready, not node ready, the node ready state or volume ready state. It should be node ready. But for a stateful plugin, it may maintain some persistent thing. And the CO need a way to tell the plugin that, okay, now the region is rebooted, the system mount table is cleaned up, but you may have some residual state you need to clean up as well. And I think this would be a good call for the CO to notify the plugin to say, you please clean up the volume back to node ready state, clean up all your residual state. Now it should be node ready. And I'm not sure if it's better if we should make this node drain call such that we should call it and terminate it and restart it again. Instead, is it possible to define the call in a way that it just reset all the volumes node ready?
The problem is, I think the assumption that you're making here is that the CO has a definite kind of source of truth that it can hand over to the plugin. And the problem is that may not always be true. So for example, when the kubelet starts, it doesn't know what should be running on the machine, and it may not know for some period of time as it goes and talks to the API server to discover that. And it may discover that mounts that were on the machine maybe should continue to exist because those volumes, or the pods referencing those volumes exist, but the kubelet itself doesn't know that. It just knows that there are workloads that are scheduled. It's the volume plugins that need to figure it out. So it becomes a little bit like it's not crisp and clear when this should be called.
But how, so in the current spec, how do we deal with node reboot?
There's no special logic for it. It's not like we call out to the plugins to let them know that the node is being rebooted. The node just reboots, and like you said, the mount tables get cleared out. When it comes back up, the kubelet is going to try to figure out what volumes should be, or what pods should be running on the given node, and essentially for those call mount again, and then the volume plugin uses that as a signal to say, okay, I have a mount coming in for this. I see that, you know, the work that I need to do for it is already done. I can just go ahead and de-idempotent and consider it done.
Yeah, but like for idempotency, like, well, I'm not sure if I clearly understand idempotency here, because from what I understand that you can repeatedly call the same call without going to a different state, right?
Right.
However, now we the volume have different states on the node. You have node ready, and then volume ready, and then published. So in a case of reboot, it is
Sorry, what's volume ready?
The volume is node staged.
Node state. So the first one you said was node ready?
Yeah, you can. So if it's not, if we call nothing on the node yet, but it's we call controller publish, then it's in a node ready state.
Got it.
Yeah, right. I'm talking about the life cycle and volume.
Yep. Okay. Yep. That makes sense.
So we have this node ready, volume ready, and published. After a like hard reboot, it is likely that the volume will just go to like all the mount tables cleaned up, and then it may go to a node ready state. Then in the spec we never actually define what when we call say publish on node ready, what will happen, and there's no clear instruction about how the CO can use the plugin to discover what state it is right now, and how to call what's the correct appropriate calls to operate on that volume.
I think in that case, I was expecting the CO will checkpoint some information about those volume being published in some state, and even after a reboot, the volume is still in something like published, and then CO the CO then will realize, oh, there's a reboot, I need to clean up, and then call like a no unpublish and no unstage volume to go back to the no ready state.
So that also means that the plugin need to be able to handle this case, right? If it doesn't know it's already published, and say if the stateless plugin, and its metadata all cleaned up because it doesn't persist any state.
Yeah, but the mount table. I mean, I was expecting the plugin will check the mount table and see, oh yeah, the mount is no longer there, and since the call needs to be idempotent, it will just return a okay in that case when you call no unpublished volume. Or a no unstage volume. But yeah, it's not being called out in the spec on this. But I think that's the kind of the expectation that I have in mind.
What about the case where storage is attached outside of the CO? So maybe for logging or something else, the volume's attached.
The CO has a way to discover that using list volumes if they want to. In general, the way that we handle it on Kubernetes is we explicitly say that if we didn't attach it, we're going to leave it alone. The thing that we use, the equivalent of list volumes inside Kubernetes to verify, is to ensure that the volumes that we expect to be mounted are actually mounted after some given time.
So how would node drain handle this? Would it be expected to keep its own state and know what is supposed to be mounted and what's not?
Yeah, that's a good question. You know, I think I think that's a that's something that is maybe a little different in CSI. Certainly in Cloud Foundry, we put all of our mount points in a known location. So it's very easy for us to identify them because they're all in a subdirectory, and we're basically just saying, well, there shouldn't be anything in there. So we're going to go unmount. If we find anything in there, we're going to unmount it and purge it. But I think with CSI, because the mount point gets passed to the plugin, and the plugin can't make any, can't know anything about that path apart from this thing exists. That's a little bit of a wrinkle. So I'm not sure.
So maybe it should come with a list of volumes, like drain the volumes that I know about or that the CO knows about.
Well, but except that that kind of defeats the purpose a little bit, because if the CO called the plugin and maybe it never heard back and it gave up on, or it called 6 times and then it decided, yeah, you know what, I'm done talking to this plugin. Then the CO doesn't really know what state the mount is in or whether it exists or not. So that would require us to do a lot of bookkeeping on the CO side to say, well, these are the dicey things that may or may not be still running here. Or maybe the plugin came back, reported okay, but actually it was trying to do something asynchronously in the background that didn't turn out to work out, right?
Well, so would this call be considered could you do the same thing with multiple calls, like a list volume and then, unpublish on each volume in the list? Should that achieve the exact same thing as this?
Well, that's assuming that the plugin still knows about these things. So if you imagine we were kind of keeping some bookkeeping in memory and something restarted. I think that does bear exploration. Like, how does the plugin know what cruft belongs to it? And maybe we need to poke at that a little bit. But
I think there's
I wouldn't expect that list volumes is going to return a list of busted stuff, right?
I understand the problem that's trying to be solved here. Like, over time, a plugin, especially if it's storing state, can drift from what the reality is. But my problem with this approach is that it's kind of depending on the CO to give it a signal when it says, clear out everything and start over. And I'm not sure that that's the correct signal in this case. I think the plugin should be looking down at the system and using that as a signal to figure out what belongs to it, what doesn't belong to it, what the CO has asked for, and rectify.
Yeah, except, well, I don't know. When we tried to do that in Cloud Foundry, we quickly got to a state where that was just too difficult in our architecture to know for sure. I guess we could have some kind of notification from the CO to the plugin to say, hey, here's the volumes I think you have running. Maybe check yourself. But that becomes quite a bit more complicated. And getting that level of intelligence between the plugin and the CO has, I think, much broader architectural implications. We picked this because, well, nothing ought to be running is a much simpler state to know about. And we can know about it at a couple points. Now,
yeah, nothing
you're
is
saying that if Kubernetes doesn't even know that nothing ought to be running, I'm deeply skeptical that you're going to be able to come up with a complete characterization of exactly what's running.
Yeah.
Right. Or how anybody's going to know that.
And I think that's the fundamental challenge with this.
And I think you're going to run into problems anyway, to be honest. Like, if you don't have any mechanism at node shutdown to keep your plugin running until your workloads are done running, that's going to potentially fry some wires anyway.
Yeah,
Like,
definitely something we need to look at on our side.
flush it all at the same time. Then, again, go back to the fuse case. That means you're terminating all the fuse processes for fuse mounts before you're done using the volume, right?
Well, fundamentally with Kubernetes, the idea is that these components can act independently of each other. It shouldn't require having to shut things down in a particular order in order for things to be in a good state. They should be able to go down like in any distributed system in a random order. And then as they recover individually, they should be able to put themselves into a good state by reaching out, discovering what's supposed to happen, and then trying to drive towards that state.
Yeah, I don't think that assertion holds true for fuse. So I mean, that's kind of incompatible with fuse. Because if you imagine like a fuse process running in a container that's servicing a mount for the node kernel, right? What happens when you terminate that fuse process is the mount effectively unmounts, but it unmounts kind of uncleanly. So if you've got a workload that's depending on that file system running in a different container and you don't terminate stuff in an orderly way, it's going to end up a little messy, and you're going to end up with, with workloads that all of a sudden can't get to their file system. And I guess I'm not sure what happens with kernel mounts, but it would be, if we're doing a kernel mount probably it's not a problem for kernel mounts, but maybe, with mount propagation. Anyway.
For the fuse case, I think you're right. There is going to be a dependency on making sure that the plugin is the last thing that terminates so that everything else has a chance to gracefully terminate. That's a good point. Going back to when this should be called. So it sounds like this call is proposed to be called when the CO is absolutely certain that nothing should be running. And that initially was right before the node restarts. And then the other proposal was that it would be when the node first starts and no workloads have been scheduled. I think the challenge is that's really like kind of impossible to say. Well,
and I guess I could, from my perspective, it feels like you could do either or, pick, because this is essentially just a housekeeping. So long as you're doing it occasionally.
And is it expected to be called in like at random points between node start and node shutdown?
I wouldn't. Well, at least for Cloud Foundry, that would be impossible for us because we can't predict what's going to happen in between. Like we know when a VM is starting up, we have kind of logic to wire to make startup orderly, and we have logic to make shutdown orderly.
So if that's the case, wouldn't the restart do a lot of the cleanup anyway? So for example, it'll shut down the container that is running the plugin, and so it's going to kill the daemon sets that are serving the mount points.
Well, again, we can't make any assertions about the state of the VM when the plugin starts because we don't know if the plugin is starting up because the node is clean and everything's coming up harmoniously.
Right. It's not the restart of the plugin itself. I'm saying the restart of the VM. Once the VM or the underlying node gets restarted, inherently the plugin container is going to be terminated and recreated, and therefore any daemon sets that exist inside it will be terminated and then will have to be recreated. And the signal to the plugin to recreate them will come from the in terms of the various publish calls.
Yeah, so I think, and we talked about that in the last meeting. I think you weren't.
I think I missed that. Yeah,
you missed that one, and I think the consensus in that meeting was we prefer not to use POSIX signals for this. because they're kind of too blunt an instrument, I guess, and also because they're not OS agnostic. So eventually we have to support Windows. We can't make the same assertions about which POSIX signal is going to be the one that.
Well, the plugin kind of has to talk to the underlying file interface anyway, right? So if anything is going to use those signals, it should be the plugin.
Yeah. So I mean, I guess that's that. I guess I see that it's a potentially viable option if you get like a SIGINT or SIGSTOP or whatever, pick the signal, you could take that as the time in your plugin to call into some logic. I guess the potentially the problem there is that if I'm a plugin author that hasn't written a container implementation, then we still have no code hook for that code to go in. So that means that in my plugin, I'm just looking for SIGINT or SIGSTOP or whatever. And I think that the consensus from James and G both was that and maybe also Brian, was that they thought that probably we didn't want to use POSIX signals. We preferred to have an explicit RPC. And then I think in your container wrapper, you can just trap SIGINT if you want and call the RPC, right? But that was the feeling.
I think that the problem with signal is like we don't even in the spec define like what's the PID of the container, like what's the process ID you want to send the signal to. Like we don't even define the process.
Well, we don't
ID.
need to, right? That's all packaging. That's all dependent on the deployment of the plugin itself.
Right, but the CO needs to know, where to send that signal to, right? Like where should I find the PID? Which process should I send the PID? Like should I send a signal to? Like Zoom, like we don't consider Windows at this moment. Like just do Zoom uses Linux.
But none of this is going through the CSI plugin, right? This would be just the plugin looking down at the system that it's running on and trying to get signals out of it.
Yeah, but if the plugin depends on this behavior, like this new behavior, then it has to be like interoperable, right? I mean, a plugin can be running on Kubernetes, should also be running on like Cloud Foundry or Mesos.
Yep. So, and that's fine. It's just that it needs to be designed in a way that it knows how to be able to, expose these signals to the plugin itself. That is a deployment challenge. It's not insurmountable. I think the big challenge there is cross-operating system, but cross-operating system, you're going to necessarily have to have different business logic for the plugin. You can't run the same, volume plugin on your Windows system that you're going to be running on your Linux system.
Yeah, okay. So I think this is not the fundamental issue. I think the fundamental issue to me, I mean, first of all, I think I don't see the connection between, so Julian mentioned the fuse example. How does that connect to the node drain issue that you discussed previously? I don't see the connection there, like why this is related.
Julian, do you want to?
I think so. The connection between fuse at termination and so I don't think it was exactly that was not explicitly connected. Only to say that. So what Saad is saying is like in Kubernetes, and correct me if I'm wrong on this, Saad, but my understanding is in Kubernetes, basically on the node, the plugin is just another container running amongst a whole bunch of containers. So the plugin and the workloads are all just peers, right? We don't deem plugin containers to be special amongst the constellation of containers running in Kubernetes. So at node shutdown, everybody gets a signal like stop your stuff, closing time, we're kicking you out, and everything has to shut down. And so I guess what I was saying is it doesn't work very well for Fuse because Fuse is not designed for stateless cloud workloads, right?
Why-
It wants
Why would
has dependencies on the kernel and stuff. So that it's related in as much as, I guess my assertion was, if you don't have a way of knowing which of these things are your plugins and therefore special and therefore needing to be shut down after everything else, you may have some problems.
on a graceful shutdown, why wouldn't the plugin just wait until everything is unpublished before it actually shuts down?
All the operator will make sure that all the workload on that node has been cleanly terminated before it try to remove the daemon sets on the node.
Yeah, so that
It's an operator's response. I mean, in a shutdown, in a node drain case, it's anyways an operator's responsibility to do those things, or CO provide some primitive allow people to do that. Yeah, I feel like it's kind of a very hard problem to solve.
Also, this is kind of assuming that the CO has exclusive ownership over all of the volumes attached to a node, right? And so if we're looking at something like Docker or RHEL plus another CO that may be using the same CSI driver to do mounts, this stuff could be mounted and used outside of whatever CO is sending this call, and then it ends up getting unmounted as the CO shuts down.
Yeah, that's another dimension of the problem. If you
I gotta say, that sounds a little unrealistic to me, and maybe that's something we want to be explicit about. But the idea that we would use the same plugin instance for both Kubernetes and Docker or Mesos or whatever running on the same VM, I mean, it feels like very much an edge case that I personally don't think we have to solve for. I think it's real unlikely.
Well, a more realistic example of that is on GKE, we'll have GCE persistent disks that are mounted for the underlying, just the infrastructure, kubelet, and running the VMs themselves. And those disks are not managed by Kubernetes. So it would not be...
do you go through CSI?
It doesn't go through CSI. It's just mounted as part of the node process.
Right. Well, I definitely don't want the plugin going and just blowing away everything it finds in the mount table, right? The plugin needs to have some idea of, ownership of mounts, right? So the idea is if the plugin is able to identify artifacts that it definitely made, and it doesn't, and they're still existing, and we know they shouldn't exist, and this gives the plugin the opportunity to do some cleanup. And that's kind of it, right? So if there's a bunch of other stuff that the plugin didn't ever make, then definitely the plugin shouldn't be just blowing it all away.
So the situation with multiple container orchestrators, I know it seems weird to have a mixed environment of Mesos and Kubernetes, but if you look at containerized operating systems, there's a good chance that we could be going through the CSI layer for some of our basic operating system mount-on-mount calls.
Yeah, and also we do have a use case for that too.
But do you imagine you would be running the same plugin process?
No, I mean, would the workflow be two Gluster CSI plugins running on the same host, and you're supposed to communicate to them through different gRPC calls? I mean, I can see that, but it seems like a weird scaling issue, right? You're supposed to launch a new CSI instance.
I mean, I don't think we would ever plan to support anything outside of Docker's existing plugin mechanism at the moment. So for us, that would just be, there's the Docker plugin, and we don't talk to anything outside of that, which is its own container that Docker manages.
Okay,
So
I think
vote on the single plugin to manage the back end, right? Not multiple.
Yeah, for us, I think we can go either route. I mean, we haven't decided which way to go. So by the way, so I think we are 40 minutes into this discussion. Like I feel like it will be more like effective if we move this discussion offline to like the mailing list. I mean, Julian, it would be nice to kind of precisely define what the problem you're trying to solve using this new RPC. Like you mentioned the fuse case, I would like to understand like exactly when the CO will call this additional RPC and in what kind of scenario, because it's still quite unclear to me, especially the fuse example you mentioned.
Yeah, and I'd like to maybe leave people with a thought that maybe node drain is a very specific case of a more general problem, which is that the CO wants to periodically reconcile its understanding of the world with that of the plugins. And we have list volumes, and that covers like part of the reconciliation, right? Because it lets the CO discover pre-created volumes. But that it stops there, right? And there's no mechanism to reconcile with like the node state. So I'm wondering if node drain is trying to really tackle this problem of state drift between the CO and the plugin, and maybe there's a more general mechanism that we could
Yeah.
come up with.
Well, again, I just we're proposing this because this is what we found that we're actually able to do in Cloud Foundry. And while state drift, it would be nice to have a better way of managing state drift. I think gets architecturally very challenging. Like, I think Saad kind of alluded to this. Like that supposes that the CO has a very clear sense of exactly what should be running at a moment. And I think in a running system, that's incredibly difficult because then all of a sudden you're in race conditions. So this was essentially the subset of the problem you're describing that we found was actually solvable. If you think that there are other...
Well, Julian, I just want to ask, can you just document those unsolvable problems in your system, like to help us understand what the real problem is?
Okay. Yeah, I try to write a little bit more.
I agree with the fundamental problem, though. Like I like what James said, that there is a potential for state skew, and we should address that. I know Kubernetes currently does not a great job of it. So there is potential for improvement here. I think this is probably a good place to start thinking about it. It may be that this is the best that we can do, but maybe there's some other approach that we can come up with.
Okay.
Yeah, thanks, Julian. So Sad, do you want to talk about 0.3?
Yeah, so I wanted to talk about when we're going to cut 0.3, what PRs are remaining, what issues are currently open. So I believe from the issue perspective, there's 2 issues that are still open. One is for topology and the other is for volume resize. The topology one, I am in the process of rebasing it. We can, if we have some time at the end of this call, see if there's any open issues that folks would like to discuss on that. Volume resize I'm not sure what the current status of that is and whether we want to block 0.3 on that or not.
Saad Hemant, yes. Yeah, so I need to I think the majority of stuff is figured out. I need to update I have mostly written it down. I can update it today, actually, like convert the proposal to spec.md and regenerate the file. So that's pretty much I have to do. So, but again, there has to be a larger discussion. We haven't had that many comments, so probably like it will take another week before we have, because likely after I make the change, there will be more comments and stuff like that. So, yeah, so it might need more time, and I don't want to block 0.3 if that's the goal for.
Okay.
Yeah, agreed.
Yeah, makes sense. I think same kind of thing applies for topology. I don't think blocking 0.3 on it would make sense, but maybe we should think about what date we'd like to cut point 3 on and then work backwards from there?
Hey, Sud, just to comment about the topology thing, I think I created a PR against your branch
Okay.
with some thinking that I had done, and this was months ago. So
Okay. I didn't get a chance to look at that. I'll take a look at that.
yeah, okay, thanks.
I hope I didn't blow it away. I was like doing a bunch of force fishes. I'll sync with you offline.
Sounds good.
So what day does 0.3? So sounds like it's past due 2 days. And how about like we don't have a like concrete timeline when we're going to use 0.3. So doesn't matter to us at this moment. But I think we should stick to the schedule if possible. So I think like we should try to do that ASAP, like maybe by the end of this month. What do you guys think?
We can try to cut it on Monday.
Okay, that sounds good to me.
Okay. And then in the meantime, we'll see if these two get in or not.
Okay.
All right, cool. Next up, do you guys want to talk about either the volume resize or the topology PRs?
Yeah. Do you want to talk about the topology PR?
Sure. So it was unclear whether James, your feedback had been addressed or not. I think the big outstanding question that you had was whether topology should be flat or should be a hierarchy of keys. Was that issue resolved, or is that still outstanding?
That's still outstanding.
Okay, maybe we can talk about that. So it's for context for folks, the purpose of introducing topology in CSI is twofold. One is to be able to inform the CO so that it can make smart scheduling decisions based on availability of a volume. A volume may not be equally available to all nodes inside of a cluster. And we want to be able to define some way that a volume plugin can communicate back to the CO to say, this is the subset of volumes that are actually able to access this. Now, the interesting thing is that from various different implementations, how a particular cluster is segmented can vary. It can be based on regions and zones in some cloud providers. It could be racks on-prem. It could be any arbitrary subdivision. So what we don't want to do is encode any specifics about topology keys into the CSI spec. We want to keep it as generic as possible. So the model that is proposed is similar to what we do with node name and controller publish, where there is a call get node name that allows the CO to advertise what it understands the name of a node as, and then when a CO decides to actually make a volume available on that node, it can refer to the node by the name that the plugin understands. And so this proposal is saying, okay, when in addition to returning the node name, the plugin can also return a set of labels that apply to that node, topology labels. And then when a when a volume is scheduled, the plugin, the CO can use that information to correlate and understand what basically every volume also has a set of topology labels, and the CO can compare those with the node labels and understand what nodes are actually going to work with this particular volume when scheduling the workload. The other aspect of this discussion is influencing where a volume is scheduled. So we don't want to just be able to make a smart decision after a volume is created, but also be able to control where it is going to be provisioned. This could be either the scheduler making a smart decision on the CO side, or a cluster administrator on behalf of an end user making a decision about what perhaps subset of zones or something like that a volume should be provisioned in. So the changes for that are on the create volume request side, and they are broken into two big components. One is I believe we're calling it preferred and required. The idea here is that you can, if you want to limit to, let's say, Zone A, Zone B, and Zone C, you can have a required list of A, B, and C. That means that the plugin must pick between A, B, or C. And then you could have a preference between that. If you allow A, B, and C, you could also say, I prefer A. So try to provision in A and fall back to the others if not possible. So that at a very high level is what this PR is doing. I believe the point of disagreement has been on whether the way that you express topology should be a verbose map of key values, or whether it should be a flat string of just a flat string. And to illustrate that, I can use an example of, let's say, zone and rack. So for example, you could have something that belongs to zone A, rack 1, and we could express that in CSI as a map where you have keys for zone and rack and values for A and 1. Or you could have a single string that is, zone A / rack B. Or you could have a third option, which is just key value, a single key value instead of a map. My preference is to leave it verbose so that the entire hierarchy is encoded into a map. My argument for this is that it allows for a richer selection mechanism on the CO side. So if somebody wants to select at a leaf node level, they can do so. But if the full hierarchy is exposed in a map, then it could allow for selection at a higher level. So if in this zone and rack example, someone can choose to also do a zone selection without having to do any weird substring matching or making assumptions about what the delimiters are. So we're not constraining ourselves in that regard. And I think, James, you preferred the flat string. Maybe you can discuss that.
Yeah, well, I think it's been a few months since I've put my head into this, but I think what I'm concerned about is that it's an overcomplicated data structure. Like these things are opaque to a CO anyway. A CO shouldn't be reasoning about the nature of these things. Like a CO is not going to know that, oh, this thing's called region and this thing's called zone, and I know that there's an implicit hierarchy here and that I can reason about. Basically, this is like metadata that's coming from the plugin to the CO that the CO can't reason about. And so in that case, there's no need to make it a complex structure. You could actually just have it be like a list of strings instead of a dictionary, right? And then if you have lists of strings or sets, right? Because these things they should really contain unique values. Then it becomes even easier for a CO to do, some set algebra, right? Or what's the overlap between these two sets, right? What's the intersection? And I think in the case where you've got it as a map, I think you can still do that. It's just the algorithm is more complex.
And the reason for that is that it gives you. So I completely agree that the CO should be everything that the CO doesn't care about should be opaque. So like the specifics of any particular key absolutely should be opaque. In this case, instead of having a list that contains both key and value inside each list item, I would prefer to break it out as a map of keys and values. And the reason for that is because it allows for the end user to do a richer selection, right? If they want to be able to select on some specific key, if that's opaque, then they can't do that. But if it is broken out as explicit keys and values, then they have the ability to do a much richer selection.
So what you're proposing is that these opaque values from the plugin are going to be bubbled up to some user interface,
exactly,
API, and some user is going to be able to do selection of these things.
Yep. Yep. So basically, we expose a mechanism by which the storage system can give whatever topology looks like for themselves, expose that in a generic way through CSI to the CO, and then the CO can surface that to the end user and allow them to do whatever type of rich selection that they want on top of that.
I mean, I'm not convinced that you can't also do that with a list of strings. I don't.
The problem with the list of strings is that you then have to understand what the delimiter is between the key and the value.
Well, the user might, but like the system wouldn't, right? Because these are opaque to the system anyway. And so ideally, if you're going to present these to the user, then there's some kind of user readable string anyway.
Well, the system has to do it in order to do the comparison, right? We have to do the comparison between the volumes and the nodes.
No, the system shouldn't be parsing this at all. These are opaque strings.
If we are going to use it to ensure that the workload is scheduled to the correct node, we have to be able to basically do the comparison between the set of topology key and values returned by the create volume response and what any given node has, right?
Right, but then why? So what I'm struggling with is this concept of like delimiters and why the system needs to know that and to accomplish that goal.
So let me see if I could come up with a concrete example to illustrate that. So what I'm thinking is, let's see. If I want to be able to select on a specific, constraint to a specific zone and rack, how am I going to express that in the system?
Well, I think you can just provide the strings represent that zone and that rack, right? The key doesn't matter.
So how do you construct that string? How do you figure out what the keys and the values are?
Well, the CO is not constructing that, right? I mean, the plugin advertises.
Well, so I guess that's maybe part of the challenge is that we want to allow the CO to be able to construct this. On the Kubernetes side, we want to make the scheduler smart enough that it can make the decision on behalf of the end user, so the end user doesn't have to make it.
But then these are no longer opaque things if you want the scheduler to understand.
They are opaque in terms of, like, we don't actually care what the specifics of the subdivision are. We just want to know that there is a subdivision and it has some hierarchy.
But there may not be a hierarchy, right?
And
like
that's okay too. If the hierarchy is flat, you know, your map is going to be essentially one deep.
Yeah, I still don't understand why the scheduler needs this to be a map. I mean, if you have strings, like if you have strings like R1 and then like R1/Z3, right? Those are just distinct strings, right? They can both be in a set. Like a scheduler doesn't need to know that there's a slash in there and that one actually refers to a region and one actually refers to a zone. Like as long as the node is returning a list of distinct strings and that you know, it can deal with volumes from, right? And a volume is returning a set of distinct strings. All the scheduler has to do is compute the intersection of those two, right? To be able to match volumes with nodes.
So I guess the challenge is then when the CO, so let's say that the user wants to constrain a workload to, you know, 2 zones. The scheduler now needs to be able, the end user needs to be able to express that somehow to the CO, and then the CO now needs to be able to use that information to construct a request to provision a volume that is only going to be within those 2 zones. And now if you have topology that is multiple levels, so you have, I guess a good example would be region and zone, or let's say zone and rack. And you want to the user wants to do it in zone A or zone B, but each one of the nodes is labeled with a single flat key that says, this belongs to zone X and rack B. You're not able to basically select at the zone level because all that you have is the leaf node. Does that make sense?
Well, I think what James suggests is that we will have both strings for leaf label and non-leaf label labels.
Okay.
Well, I think what I'm suggesting is that in this case, you'll have like your node will have like, R1, Z2, or whatever, right? Because that's, or maybe you're, I don't know what the constraints are, right? In terms of like how volumes can be provisioned to nodes in this case. But if you've got fully qualified, if each string is like a fully qualified topology address, right? Well, it could just be R1 or it could be R1Z2, R1/Z3, like whatever. Like I don't understand how that stops the user from saying, oh, I can pick R1Z2 and R1Z3, for the volume that I'm creating, right? Because that's
the problem. I think there is that you have the value, but you don't understand what the keys are that you're selecting on.
But if we are going to use this key value map, then does that mean we have a convention for different CSI plugin to use the same set of keys?
No, not at all. For every single plugin, the plugin defines what it's exactly like the get node name concept today, where every plugin defines what the name is for a given node, and the CO keeps track of that per plugin. The idea would be the same here, where every plugin defines the topology information for every single node and volume, and the CO keeps that mapping for that plugin.
So in your example, Saad, you said there's no way for a user to say, oh, I just want to specify the region and have that mapped to all the zones. That intelligence should belong in the plugin, right? To know that, oh, these zones are sub things of this region. Why couldn't the plugin be responsible for populating the permitted list with all the zones for a region? Why does the CO need it to know anything about it?
The CO needs to be able to, I think what it boils down is the CO needs to be able to understand that keys and values are different, right? Like when I select on a zone, how can I express that for this given key, I want these 3 possible values?
But the CO, why does the CO need to do that? So say I'm making a create volume call, right?
Yep.
And I'm creating this volume and I'm saying, make me a volume in region 1.
Yep.
Right? So then the plugin comes back with a list of strings that say R1Z1, R1Z2, R1Z3, R1Z4 are all permitted, right? So that's just a bunch of opaque strings. The CO now knows, oh, I can pick any node that advertises that it exists in one of these 4 strings. So I guess where's the point where the CO needs to be able to do that extrapolation?
Well, it's when you schedule the workload, right? You need to know like where you can.
But when you schedule the workload, it's just getting the response back from the volume, which already has a list of all.
No. When you're scheduling, there's 2 steps to it. There is the after the volume has been provisioned and before the volume has been provisioned. So before the volume has been provisioned, ideally the CO would like to make a smarter decision about where the volume is provisioned and be able to express that and kind of reason about it, right? And if it's a completely flat hierarchy, that is going to be very difficult to do.
Okay.
Okay, guys, I have to go. This it's already 5 minutes over the meeting time. You guys can communicate.
Yeah, maybe I'll set up some time with James and we can just talk offline. I think it might be a higher bandwidth than going back and forth on the PR.
Yeah, that sounds good.
Yeah,
Right,
sounds
thanks.
good to me.
Thanks,
guys.
Scott. All right. Thanks, guys.
Bye.
Thanks.
Bye-bye.
See you.
Thanks.
Thanks. See ya.